how do you actually, because we currently talk about the edge, right? Later on, next section, we will talk about the network core, right? So network edge will focus on which? Network core will focus on what? I hope you understand, because if we want to talk about the network from edge and the core concept, you need to understand what's the difference between those, right? Guys, what's your current feeling regarding what is network edge?
It is the connection point of line.
Edge is what?
It is the connection point of both server points where it is connected.
So client and server is a very important concept, but regarding the whole picture, is not necessary. From application perspective, client server architecture is important. Guys, edge is more from application perspective, right?
Yeah.
Edge devices, what they want. What they want is they want to access the internet. Make sense? That's why we have billions of all kinds of different kind of edge devices. We could call host or edge devices. Make sense? All those kind of like the home network, like enterprise, all those whoever want to access the internet is network edge, right? Then network core. If you think about in this middle part, do you think network core care about what kind of application you are using?
No.
What their job is, when you have a data packet passing through,
Right.
I will just based on the destination address, but we just divert, passing through to corresponding destination. That's the network core's functionality in there, right?
Yes.
Makes sense. So in that sense, you want to see, of course, the middle part is network core. Then in each search access network, you also have a very important server. We typically call it what? Edge server. They will connect to the network core, right? Mm-hmm. Make sense? For example, in your home, how do you access the internet? You are paying the SP, right? The SP, you need to have devices, right? It's kind of a router, currently router access point. Everything's combined in those devices, right? Make sense? This is a server as from home network to the network port. That is more like an edge server. Of course, from the enterprise like Prairie, they might have multiple edge servers to connect to the port. Make sense? Makes sense, right? Think about those concepts. This way should the wireless communication link. So access network is how to connect any system to the edge server. That's an access technology perspective, right? As long as you access internet, regarding how network core function, the focus is kind of slightly changed. Make sense? Okay. So, page summary here. Edge server is the first router that links the end system to the internet. Remember the edge router concept. Then from the access technology, we already talked about the DSL, talked about the cable, talked about the fiber, right? The dial-up is the old technology. It's kind of not popular, but used to be popular. That's why I changed the color. Satellite and the wireless part. That's some popular access technology. Okay, from home perspective. From like Prairie enterprise, typically either via Ethernet or Wi-Fi. That's too popular. Makes sense? From home, we might have a different scenario. Then wireless area. Wide area wireless network, that's basically a cellular network. Makes sense? The base station type. Data center, we have a section there. Later on, you have time to talk about data center. It's totally different technology. I don't know what happened to the door. Maybe close it. For the cable network, like I mentioned, it's based on the old traditional, like I used to live in the East Coast, right? They have their their traditional TV network, which is cable-based. Then later on, they added a little bit frequency division multiplexing technology in there. Then it split the different channels. Sub-channels is for the video part. Sub-channel is for the data part. Okay? Yeah, go ahead.
So when you say cable network, that is shared, and the DSL is cable. The users have individual lines, and the cable is shared. That's the difference between the cable and the DSL.
The cable, yeah. You see? Cable, see the same cable, different house code put the link the same cable. That's basically what the cable depends how the network originally is set up. For the original, remember I used to, that's why I first from the East Coast moved to here, how to get the TV network a long time ago. It's different. In there, it's so cheap to get the cable television there. But here, I think in Texas, the cable network never get popular. That's my feeling. There, you already set up those kind of cable network. You just add some devices, then you can access the internet. Make sense? Because same cable runs through the neighborhood. They'll get something to your own house. That's why it's a shared medium. In that case, why in the midnight when everybody's sleeping, access the internet is getting much faster because the whole network you have a little bit fatter share in that case. That's for the shared medium case. But in that case, I want you to pay attention to what is FDM, frequency division multiplexing. Same frequency, some is left for your still watching the TV part, the rest is for your data communication. Then they have the different frequency division, sub-channel in there, makes sense? And currently, guys, for a certain part when the fiber technology is getting popular, actually you have the hybrid fiber and the cable network together, makes sense? So when the ISP part from that local ISP to in that part they could be changed to fiber device to increase the speed. For the DSL, remember your phone line is private to you, right? Your local ISP only have one specific phone line to your house. That's why DSL is not shared medium because you have your own phone line there. Only for your own phone line. But now, I guess it's totally different. It's still like based on the traditional way. You'll have your own phone line coming to your house. Then some could still using your phone, some for your internet access. Okay, that's basic. That's why it's not shared anymore. Now it's basically you still have a line. Mostly from a fiber or still using DSL, but nobody is asking for the phone service anymore. Some still, it took me many years to finally decide to get rid of my wired phone line. It's just in case, it took us so many years. But actually, we are not, who still have the wired phone number? Only cellular phone number, right? If you're for international, of course you have cellular. But if you're a house, it took me so many years to make this decision to get rid of it. But the thing about DSL is based on that network to add the internet access. Okay. Then also another characteristic, remember, the concept is a symmetric network. Basically, we have uplink and downlink, right? Mostly, we are not what? We are not not like provide contents. We are just consume contents. Mm-hmm. That's why the downlink, the speed is higher. The uplink is lower. That's basically both. We call it a symmetric kind of characteristic. Make sense? Okay. Both for cable and the DSL. Okay, good. DSL. So I want you to pay a little bit attention for this frequency division multiplexing part. For the frequency, you guys heard about we have FDMA, we have TDMA, right? Time division multiplexing. We also have for the wireless, we also have CDMA, right? Code division multiplexing, right? Just hope you kind of in that concept know a little bit about those. You guys who heard about FDMA? Guys, raise your hand. TDMA, multiplex. You guys know a little bit about those, right? Basic, that's related to more like physical layer, how to access, how to physical and the data link layer, how to share the channel, right? Just pay a little bit attention because later on when we move on to network core, we may need to revisit what is TDMA, FDMA, so on and so forth. Make sense? Just the channel, how to separate the channel. You have a frequency channel. We use on different frequency. We have sub channel. Then each sub channel we could assign for different usage or different user. For the time division multiplexing, we have a different time slot. Each slot is assigned different user, different sub channel. Make sense? Make sense? Just basic different way to doing the multiplexing part. For your cellular, when we first have the 3G third generation, it's based on the code. Although everybody is using the same frequency, same time, but when you have different code, make sense? You also have the different sub-channel part. Just how to do in the multiplexing part, okay? Because later on that will be important. Then asymmetric part. And the twisted pair is very popular for what? Ethernet, right? Even the phone line. DSL cable, then currently fiber to the FTTH is getting popular. It's also much what? Faster, right? It's not nothing, not cheap. I don't know your guys' rate to access the internet. Depends on the speed. It's not that cheap, but it's getting better. Then if you are nowhere, no ISP want to provide service, you can use in the satellite. Then for the this is an old technology. When we using dial-up, using your phone line, right? For the satellite, guys, what's the pros and cons for the satellite? When you try to access the internet using the satellite. Even the satellite technology recent years is also have lots of improvement. Make sense? Based on your basic guess or intuition, what's the possible problem with satellite?
Weather.
It's slow.
Slow. Your answer is?
Weather.
Oh, weather also makes sense. It is slow.
Still a time delay.
Yeah, the delay will be a little more, right? But the reason that even the satellite they have multiple layers.
Yeah.
The delay is also improved a lot. But the reason why I want to ask this question is, think about when you have network communication, right? We have request and reply. The network product, we have a sequence of the data packet passing through. So sometimes if your server is really local, when you send a request, you can reply really quickly, right? Then for people, for us, patience is never good. We've never been that patient. So sometimes when the delay is a little bit too much, they might think, oh, maybe the channel is lost, the communication, we will restart. Makes sense. That's the basic for different kind of communication. That's the performance part. The delay might be an issue. Okay? That's for the satellite part. But even now it's getting much better. Okay? Okay. For the home part, guys, mostly the ISP provide your device, right? They basically the router also provide some kind of security, provide some kind of access point. That's why you can set up the Wi-Fi in your home, right? Back home, guys, try to run IP configure yourself. Okay, please check about when you try to access the internet, what's the IP address you're using. Try to do this. Okay, next time I will ask you guys. Okay, what's the IP address when at home when you try to access the internet? What's the IP address you're using? Okay, try to do this. Okay. wireless, we already talked about it. One is Wi-Fi part. Okay, you guys are using. The other one is a wide area basic cellular network. Okay, Wi-Fi is what? Fast. The transmission rate is high, but error is
Small.
That one is slow, but
Wider.
that's the difference. Okay. For the enterprise, we already mentioned mainly is either Ethernet or Wi-Fi, right? For your. So far so good. Okay. Now, for example, somebody is checking the internet, right? So when you're doing any kind of activity, what's happening in there? For example, you are trying to submit your homework or try to check your email, right? When you start that task, what's happening in your side? Anybody have those kind of thoughts? Of course, you will start an application, right? We don't know what application you're using, right? But for your application, from application layer, right?
Yes.
For example, it's HTTP. You're trying to access the internet, right? Then what will happen then? We start your application, you work with your application layer, right? Then your operating system might help you have a packet, right? Make sense? Basically, for example, if you want to access, for me, my private email is still a Yahoo email, right? I'll go to the Yahoo, check my email, right? For example, that's the case. You have your source back home, check your source IP, right? Then you want to go to some destination, you have your destination IP address, right? Of course, you have different application. The application start doing something, right? Right? Make sense? Then the application, the job you want to do is what? Later on, you need to pass on this task to the lower layer, right? You need to pass on this job eventually to transport layer. Transport layer need to pass on to the network layer. Network layer pass on to the link layer. Then eventually, they're the one through some physical media send it out. Make sense?
Yes.
Then they go through the internet. Might go to multiple hubs. Finally, go to destination. Then the information from the physical layer
Go back up.
to the go all the way back DSL, go to the network, finally network check your IP. Oh, this is for me, then go to transport, then go to the specific application, the server part, maybe the server side you're working on. Makes sense? That's basically the flow, the information flow. I hope you understand first the information from the top layer all the way to the physical layer, send it out to multiple hubs eventually. Later we'll talk. Eventually at the end side, all the way back up to the top layer. But from your sense, it seems like application, client side application seems to directly talk to the server side application. But that's not the case, right? Data flow, everybody kind of hope understand, right? Second thing is, when you have a big task, right? For example, you're sending a big file. Did actually the whole big file actually send through the network? Not necessarily, right? So in that case, that's why I want to introduce the data packet concept. Makes sense? You need to break those up. If you have plenty of information, you can understand that the big chunk of information all together, right? You need to break into small chunk of information. Make sense? Got it? That's basically how the data packet concept. Then for the application data packet, then you need to add what? The header part. When you move down, you add another header. You have the encapsulation concept. Make sense? Later on, add all the header. Think about it. When you move down later, you need to trace back where it's coming from, what is this for, right? Make sense? All those things all depend on the header. Each header, we have all kinds of different fields that associate the corresponding network protocol. Make sense? Right? So far, forget about those. Think about when you have an application message, you have different packets, right? The packet you need what? Send to the network. That's basically, I hope at least you have, actually the packet is start from the application layer, pass on the transport, pass on the network, pass on this thing, and eventually send it out. Make sense? But you need to understand it's not the whole thing. You need to break into packet. You need to send through the network. Got it? That's basic. This concept. Your packet length, you have a L, but the packet itself have original information, all kinds of headers in there. This part in your mind, at least know a little bit. When you send through the network, right? Push through the network. Then you have a network transmission rate is R, right? Then in that case, we might have all kinds of delays in here. In this case, it's called transmission delay. It's your packet length divided by your transmission rate. Make sense? If your rate is higher, it's lower time, less time, right? If your rate is, for example, if you're, like I mentioned, if you're nowhere, you have to use in your cellular network. Typically, cellular network rate is not high. That's why you only can do simpler application, right? The transmission delay is related, is L divided by R. Make sense? Guys?
Yeah.
Then later on we will have all kinds of different delays in there. Later on we will talk about, okay? But at least understand the transmission delay here, okay? Then the beat, 101 bit, right? 8 bits is a 1 bar, right? Make sense? Then we have a K, we have the rate could be K is 1,000, right? M is 10 to the 6, right? 1 million, right? So typically when we talk about the rate, it could be 100 megabit per second, right? M is 10 to the 6, right? 100 kilobit per second, K is 10 to the 3. We also sometimes, if you're Ethernet, your transmitting rate might be in the gigabit per second. Then the giga would be 10 to the 9. Make sense? That's basically all related to bit, then corresponding transmission rate in there. Okay? Right?
Yeah.
This is easy. Guided media mostly is wired, and unguided mostly is wireless, right? You guys see, when you have the Ethernet part, mostly goes through the twisted pair. Ethernet packet with the allowed rate is different, and the cable is more complicated, supporting the rate typically higher. When you go to the fiber, the rate is even higher. Okay. This is they already mentioned. We can ask, right? The linked and the wireless part. Guys, how about we just finish watching this part, and the next time try to figure it out. We have another quiz working on. Next time come back for another quiz. Okay? We done with network edge. Then we move on to the network core. So in your mind, after all those intro, what's the major appliance in the network core, guys? Routers. Yes. All kinds of routers, right? So for the network core, what's the key concept in the network core? Basically, network core mostly is just IP address. Okay. Basically, it's just routing through, passing your data packet, right? The routers only works through the network layer. Of course, the IP routing is important. IP address is important. Another key concept I hope for the network core is you guys heard about what is packet switching and the circuit switching concept, right? So what's the difference of packet switching and the circuit switching? And that's the first thing, because we're almost there. That's the question, guys. I hope you start to think when you read. When you have the question, you push your to get what is the difference of packet switching and circuit switching? Second question is, what is the internet-based? Is the internet-based circuit switching, or the internet is based on the packet switching technology? Why?
datagram that is sent or the messages that are sent in packets. They are not sent in the
For the circuit switching, we can also use the packet. We can also split into your original data into different packets. The packet is not the key reason what is a circuit switch or packet switch. Guys, that's a really important question. Okay, we'll watch this. We'll watch the network core, this part for now. But remember, those are really important questions. For the internet, it's based on packet switching and circuit switching. Then question ask you guys for the packet switching and circuit pro and cons for each different technology. Make sense? That's what we do. Because that's one of the fundamental questions for the internet. Okay.
We're going to overview the network core. We're going to see what happens inside the network core, and we're going to introduce a number of important topics. We'll talk about packet forwarding, packet queuing delays, and packet loss. We'll talk about an alternative to packet switching known as circuit switching, and we'll talk about the structure of the internet. We'll see what we mean when we say the internet is a network of networks. The network core consists simply of a set of routers that are interconnected by a set of communication links. And the internet's core operation is based on a principle known as packet switching, which is really relatively simple. The idea is the following. What happens is that the end hosts that we talked about earlier take application level messages, divide those messages into chunks of data, put those chunks of data inside packets, and send those packets into the internet. Now, those packets are then forwarded along a path from a source node to a destination node. For example, from a web